have you taken into the account the parameter of albedo? Like if there is ice melting, then it will be warmer and it will change the albedo. So is that taken into the account, the feedback mechanism of albedo for the parameters which you have considered?
So the simple model that we used doesn't in itself have any of the complex feedbacks that you find in the more sophisticated models, but it can be tuned to emulate the models from the COP25 ensemble, the more complex climate models, and so it can reproduce the more complex behaviours if it's tuned to do so, but it doesn't itself have any of these like complex feedback mechanisms built into it. So it's a simple emulator.
Thank you so much. Sandra Guzman from the Climate Finance Group for Latin America and the Caribbean. And this is a question for Valerie. I had the opportunity to be a participant in the session yesterday about the implications of the report in Latin America. And one of the things that I wanted to really ask to the authors is precisely about the response that you got from the negotiators. You were mentioning the importance to bring this information to the actual negotiations, and this is such an important moment for us to accelerate the process. So I would like to know, do you think that the response has been like the one that you wanted when you presented this report? Or what do you think that is necessary to keep pushing for this information to really change the trajectory of the negotiation here in Katowice?
I can just say that I'm very positively surprised by the enthusiastic response of those present here, negotiators, but also people from the civil society, the curiosity to better understand the reports, the implications of the reports, the appropriation of the report's findings in specific regional contexts, and also to express the fact that part of the surprise is how many thanks we have received for the report and for the clarity of the report as well. So it now belongs to negotiators to make the best possible use of the knowledge.
Can I chip in, actually? Can I chip in on that?
Okay.
Yeah, sorry, just to say, as an author, just to add to what Valerie's just said, I was so impressed in Incheon by the very constructive attitude of the government delegations. We had a lot of really great support from delegations in clarifying the report and in engaging on these quite technical issues. I mean, when we found ourselves discussing with government delegations about the precise definition of global average surface temperature versus global average surface air temperature, you might think this is a bit of a sort of nerdy meteorologist's problem, but governments understood why it was important, why we cared about it, and they took this all very much on board. So I just wanted to emphasize how impressed I was at the constructive attitude there. And I think that's very encouraging. It shows that we have a very solid understanding and grounding of what's important on this issue going forward.
Thank you, Miles. And then next question there.
Thank you. Ricardo Navarro, Friends of the Earth, El Salvador. When you try to predict the future, the temperature, the atmosphere, given the emissions that we think humanity is going to send, you are assuming that the atmosphere is going to behave in the same way that it behaved in the past. The question is that real? How about positive feedback effects? How about the methane hydrates? I don't know if you have seen the reports in the northern part of the Arctic, in the eastern Siberian Arctic shelf, for example. They are showing, huge emissions of the methane hydrates. Couldn't we have the danger of going above the tipping points? How do you feel about that?
That's a question for Miles. Miles, did you hear that?
Sure, I did. Yeah, no problem. Well, there's two sides to this. First of all, it may sound surprising, but in a sense, the ambition of the 1.5 degree goal makes the modeling task almost easier, because you're constrained not by scenarios or by climate models, but by geometry. Unfortunately, I'm waving my hands, but you can't see me, but you have to imagine me waving my hands. But I mean, if we are rising, if temperatures are rising at 0.2 degrees per decade, and we are already at 1 degree, there's very few temperature pathways that will stabilize at 1.5. So that tells you immediately what has to happen to emissions if we're going to halt the warming at 1.5 degrees. Now, what happens after we halt the warming at 1.5 degrees, the report does note, and I draw your attention to also in the SPM, we note that in the summary for policymakers, we note that it is possible we may need long-term net negative emissions in order to compensate for these Earth system feedbacks that you mentioned. So you mentioned it is a very important piece of new science that we are recognizing that the Arctic could start to release carbon at a rate that would require us in the long term to actually take that carbon back out of the atmosphere to compensate for those long-term releases. And that's an important new piece of science which is highlighted in this report. So we have a challenge in front of us, not only to stabilize temperatures at 1.5 degrees, but in the longer term, we may have to keep working just to hold them at 1.5 degrees and prevent carbon dioxide levels starting to drift up again because of these Earth system feedbacks. It's a very important new piece of science which is highlighted in this report.
Thank you, Miles. And Valerie would like to add a few words to that response.
And I should stress actually Valerie knows much more about this than I do actually, so over to you, Valerie.
Just 3 points. The first one is that the timing when we would enter a 1.5 degree warmer world has also been assessed based on state-of-the-art complex climate models. It was done in Chapter 3, and if we emit more greenhouse gases, it's earlier, as expected from physics as well. So it's also reported in Chapter 3 and a detailed annex. The second point is that this report has assessed for 1.5 degree warming the potential carbon release due to permafrost thawing. It's identified as one source of uncertainty with an effort for quantification. And third thing, many potential abrupt changes are linked with the ocean and the cryosphere. And the special report on the ocean and the cryosphere in a changing climate, which is currently under review, has a specific chapter on these aspects. So new knowledge will be assessed and be available in the ocean cryosphere report with respect to your question.
Next question over there, and then it's you.
Thank you so much for your presentation. My name is Kelechi Elaya from Yale University. I was just wondering, you might have addressed this, but I was hoping to find out if you have information about the regional temperature, the areas that are priority for the warming, like the regional on a regional scale, that may help to inform some kind of response. That's my interest.
Valerie, would you like to?
So today the focus is on Chapter 1, but Chapter 3 has a lot of information on the regional characteristics of a 1.5 or 2 degree warmer world. It also has a specific table, table 3.6, on regional hotspots and what can be provided as a function of global warming below 1.5, between 1.5 and 2, and for more than 2. So you'll find maps as well as a table with regional hotspots in Chapter 3.
And then you have a question.
My name is Don Brown. I'm from Widener Law School in the United States. I'm an author, IPCC author of Chapter 4 on equity. The feedbacks, you did a good job of answering some of my questions, but it's not only the methane feedback that could happen. Ice feedbacks, ocean ice feedbacks are not in runs, and there's a paper by Stefan et al. That came after, that said that multiple feedbacks are actually now possible between 1.5 and 2 degrees centigrade, which is, for me, new information. Any comment on that?
Would you like to say something?
So the Chapter 3 has assessed knowledge based on published literature, timely for the cut-off dates of this report, including papers looking at climate model results and what abrupt behavior is produced by climate models. It's available in Chapter 3. The paper you quote was not assessed. It was published after the report. And it's part of the material that is assessed in the Ocean Cryosphere report specifically.
Can I just chip in regarding that specific paper? It was largely a sort of review paper drawing on other published papers about these tipping points and so forth. So many of the papers that were cited in that Stefan et al. Paper were assessed in this report. So, you know, the academic literature is building on itself as well as us drawing on the academic literature. So it's important to stress that I don't think the Stefan et al. Paper that you referred to introduced any particularly new mechanisms, but it drew together the risks in a way that was also assessed in this report.
Is that a follow-up to the, or a new question?
Well, the Stefan et al. Papers actually claimed that some of the feedbacks were not in the previous IPCC report. They're claiming that AR4, AR5, the models, the predictions have not been in some of the IPCC work. And it's been explained to me that a lot of people thought that the literature said that they wouldn't happen until 2 degrees centigrade, but now it looks like, according to the Stefan et al. Paper, it could happen between 1.1 and 2 degrees centigrade. So if that's true, that's a big story, it seems to me.
Valerie would like to ask.
So I want to stress that Chapter 3 reports a number of potential regional tipping points. Most of the literature shows it occurs from 2 degrees or more with low confidence. And then in the reasons for concern and the burning amber diagrams, the one for the last one, linked to potential abrupt change, the risk has been revised upwards, but with low to medium confidence. And this is especially because we don't know what level of warming would avoid destabilization of sectors of the ice sheets and associated consequences. So this has been captured based on existing knowledge by revising upwards that amber in the range between now and 2 degrees.
And then there was a question over there.
Hello, Franco Montalto, Drexel University in Philadelphia. I just had a question about, the scenarios all end up at a net zero eventually. And I'm wondering if the modeling or the results that are reported differentiate between different ways, of course, that you could have net zero. I mean, spatially or just in terms of the different emissions and sinks of carbon. Does it matter how you get to net zero?
Maybe Miles can add to my response, but here we consider not regional one, but the global mean surface temperature, and using the simple climate model, we adjusted we estimated these hazards.
Can I answer that?
Miles?
Yep. Just to say that CO2, because of course it's well mixed, you need emissions to be net zero globally, but other agents are more complicated because they have a regional forcing signature, and there's a lot of discussion actually both in the chapter and in other chapters about the interactions between CO2 and other drivers of climate change. In fact, we have a little box, which, as well as the box on pathways, which is led by Mikiko, we have a box in Chapter 1 on different drivers of climate and how we understand their interactions in approaching net zero. And you're quite right to highlight there are some subtleties in the definition of net zero, and so I commend that box to you.
Valerie would like to add something to that.
Yes, I think the report also opens new research directions. For instance, if you are at net zero CO2, it also means you have changed your land use practices, land cover is different, there are biophysical feedbacks. If you reduce emissions of black carbon or methane, you act on regional climate forces. It has implications for characteristics of regional climate change. So there's a need to produce new knowledge, to put better light on what it means for regional climate characteristics in the various 1.5 warmer worlds that can be imagined.
Next question there.
Vargas Association of Polish Cities and Urban Program, European Program for Sustainable Urban Development. I don't know yet the report, but I have a question concerning if you have calculated the influence of cities on the global warming and what are the provisions for the future on the influence of cities because they are growing and they will not stop growing in the future, in the near future.
Would you like to answer that?
Maybe yeah. Anyway, the cities is from the point of the mitigation. Cities in the very important issue, and now the more than half more than 50% living in cities, and the cities are growing, and mega cities, number of mega cities growing, and within the cities, temperature is more than the average, of course, and so now the in the mitigation, the part, what method we need to reduce, how to reduce emissions. The cities is one of the most important, and for the city planning. Now I'm from Japan, and belong to the Asian regions, and the Asian mega cities are growing and growing, and so at the same time there are some. So, for example, shelter. Now they are used only they move to the electric cars, not to the fossil fuel-based cars. So the cities planner are always thinking about these low-carbon cities. And in Japan also we have the low-carbon city initiative, and many cities want to be low-carbon, but still I'm afraid under development. But they are looking for many strategies.
Valerie wanted to add.
Yes, sure. There are elements specific to cities in the chapter 3 on the impact of a warmer world. Lots of elements on well-being in cities, and in the chapter 4 about systems transformation, there are also lots of options related to cities with respect to adaptation, with respect to mitigation, their synergies, and how they can be combined towards a climate resilient development pathway for cities. So lots of elements. And on Monday afternoon there's also an IPCC special event on the agenda for knowledge and action that has been proposed from the city's IPCC conference, so that there's a better involvement between local practitioners and scientists to produce and use knowledge that can be used for action at city scale.
Next Monday, yes?
Next question there.
Thank you. My name is Małgorzata Ćwiek, and I work at the United Nations Economic Commission for Europe. And I have maybe a little nerdy question about the definition of the temperature change. When we talk about regional impacts, how did you approach that in the report?
Would like to answer that, Enrico or Miles, or?
I'm the nerd here. Yeah, that's fine. So when we talk about regional impacts, we anchor those to the global temperature change. So when we talk about regional impacts at 1.5 degrees, we mean the impacts we expect in a particular region, or at a particular location, or particular altitude, or whatever, when the global average surface temperature reaches 1.5 degrees. So as I emphasized in that map with all the little dots on it, this of course could mean much more than 1.5 degrees in a particular region. So for example, in the Arctic, we would expect temperatures to have risen probably by at least 3 degrees in many parts of the Arctic in several seasons, by the time global temperatures reach 1.5 degrees, because the temperatures are warming more than twice as fast in the Arctic than they are globally. So that's what we mean by impacts at different levels of warming. On a sort of additional to that, one of the points that Valerie mentioned about there being different types of 1.5 degree worlds, one of the points we make in the report is that the way in which you approach 1.5 can actually affect the relationship between local temperatures and global temperatures. So this relationship, we use it a lot, but it's not unique. And it is important to understand the pathway to 1.5 degrees, as well as just the overall temperature level in defining regional impacts.
Next question there, please.
Sebastian Richer from GSOC. I would like to ask you a question regarding the work from IAMC for the IPCC. How the consortium for the IAM can help you? What are the tracks you foresee in the near future? Thank you.
You mean the Integrated Assessment Modeling Consortium? Yes, Integrated Assessment Modeling Consortium works a lot about scenarios, and it was just started at the time of SR1.5, and we first collected the starting point is we have collected scenarios and we developed the scenario database. And then many modelers put their data in the same frame, and now we are working on this scenario database. And for the chapter 2, this report, we show the pathways, lots of pathways. And all pathways are in the database. It has a database, and you can of course see. And in chapter 2, we extracted four stylized scenarios: P1, P2, P2, P3, P4. All these data are now in the database. And now such kind of database are very important output from the IMC. And also now IMC are working for the future. And also the IMC group first developed the SSP scenario, which is used in SR5, and now the shared socio-economic scenarios. Now we have the scenario for the 1.5 PVC, and so this kind of work done by for the SSP scenario, so shared socio-economic scenario. For the modelers, it's very important to have the common future scenarios. So the global scenario we have developed, but now many people are interested in city-based scenarios. So city SSP scenarios are now developing, and also the so how to the more mitigation scenarios, more deeper, and now we are working also the not only this scenario itself, but how this transformation, this report, the SR1.5 focus on this system transition, fast and far-reaching system transition. And how can such kind of system transition can be achieved? We need more sector-wise scenarios. So the IMC group, some of IMC groups are working on such. Okay, thank you.
Can I just chip in, because Mikiko may be too modest to say so, but this time the integrated assessment modeling community has actually done a really good job of publishing all of the integrated assessment modeling studies used in the 1.5 degrees report. And I'm speaking here as a user of these scenarios, not as a generator, so I can praise them without blushing. And all of those scenarios have been published. They've got a great sort of interface, so you can download them from the IASA website. And this is a great development, I think, in terms of transparency and allowing people to understand exactly the scenarios that have gone into the 1.5 degrees report. So I think publishing those scenarios has been a really good development, which IPCC has managed to do. And there's a lot of work which went into that. So I think the integrated assessment modeling community needs to be very much applauded for that.
Thank you, Miles. And Valerie would like to add.
Yeah, and the report also identifies a number of ways forward. For instance, more transparency on the underlying assumptions and maybe the codes of the integrated assessment models, as done in climate modeling, for instance. And another way forward is a better representation of processes related to land use, land cover in the integrated assessment models. This is particularly important for some of the greenhouse gases.
One more question there.
In the summary for policymakers, there's a statement that said cost-benefit analysis is not appropriate for this. And I didn't know that that's the kind of thing you would get into. Is there deeper discussion in the report about those kinds of issues? Okay, so they did some equity, justice things in this report.
So who would like to answer that?
So for the cost-benefit analysis, I also agree that only cost-benefit analysis is not adequate because we are not talking about the benefit of some policies, but we are talking about to avoid the impact of the climate change. So we not only the cost efficiency could be we need to think about, but we focus more about the of course model can provide how much investment we need and what the revenue, but the short term it could be a cost, but in the long run the energy efficiency investment we have a gain, and this can be compensated. So so the policies are required to increase toward this low carbon future. So not only this such kind of the value estimate, but also the policy is I think very important.
Can I chip in on that one? Yeah, just briefly. So you mentioned ethics and equity, and it was certainly recognized in Chapter 1 that ethical considerations play a big role in the application of anything like cost-benefit analysis. And we actually recruited, at the suggestion of governments, a specific lead author to our chapter who was a specialist on philosophical issues relating to ethics and equity, Stephen Humphreys, and so there's quite a lot of material in Chapter 1 and also in Chapter 5 on the ethics and equity dimensions of 1.5 degrees.
Thank you, Miles. Next question there.
Yeah. In these models, the impression that it gives is that the world behaves only in a physical way, and reality is different. For example, if you increase the temperature, there will be an impact in the bacterial respiration of methane, and that is not included in the models, because that has to do with biology. If you increase the temperature, like in the overshoot, bees might end up collapsing, particularly because of all the neonicotinoids that are throwing Bayern and all these corporations, you know? Now, even if you bring the temperature down, the damage will be done. And my concern is that how can we put that into some kind of analysis? I understand is extremely difficult, but nevertheless, we gotta have an idea of what to do.
Who would like to answer that?
I can say something about the figures that I was involved in that they are designed as a schematic to give an example of the global response to an emission scenario. And as such, they're done with a simple climate model that doesn't have a lot of the feedbacks that you're talking about included in it. So it's designed to give more of a first analysis, understanding of the scale of the response with respect to CO2 or other forces, and when you change something, what happens. And I'll probably pass over to Miles. There's other chapters in the report that consider more fully feedbacks and analysis around those. So.
And on these Earth system feedbacks that you refer to, there is we did recognize the emerging literature on this, and those papers were assessed. Actually, they were primarily assessed in Chapter 2, but we noted them also in Chapter 1 and their importance. And again, it's important to understand that achieving 1.5 degrees will to some extent be a matter of learning as we go. We don't know yet what it will take to limit warming to 1.5 degrees. The report is very clear on that. We can make an estimate based on what we know now, but as soon as we start reducing emissions, we will learn more. And as we approach 1.5 degrees, we will learn more, we will learn